You ever wonder how your food delivery app magically talks to the restaurant's kitchen? Or how your phone knows the weather forecast like right now? Well, the answer to that, almost every single time, is something called an API. These are the application programming interfaces, and they are, quite literally, the invisible architects of our digital world. So today, we're going to pull back the curtain and look at the blueprints that let all this amazing software work together so seamlessly.
Now, to really get APIs, you have to start with this one crucial idea, the specification. And I want you to stop thinking about code for a second. Think of an architect's blueprint, not the finished building. A specification is that blueprint. It's a formal contract that lays out all the rules, what you can ask it, and exactly what it promises to give you back. This is the bedrock that everything else is built on.
And right here, this is the most powerful concept of all. We separate the blueprint from the actual building. See, as a developer, you don't write your code to talk to the building. You write your code to talk to the blueprint, and that is a total game changer. Why? Because it means the implementation, the building itself, can be completely torn down, renovated, or upgraded. And as long as the new version honors the same blueprint, your code won't break. It won't even notice.
And the best part? You don't have to draw all these blueprints from scratch. Platforms like Jakarta EE give you this massive, standardized toolkit of specifications right out of the box. It's like having an entire library of professional, battle-tested architectural plans at your fingertips for pretty much anything you need to build, from web services to database connections. Okay, so if a great application starts with a great blueprint, let's talk about how to make one. We're going to dive into the first phase of the API lifecycle, designing a REST API. This is all about architecture. We're planning the structure and the rules before we even think about writing a single line of code. So before I just list off the rules, take a second and think about it. If you were designing one of these blueprints, what would make it great? What would make it easy to use, easy to understand? What would make it strong and able to scale up? What's the secret sauce here?
Well, a really solid REST API is built on three core principles. First up, statelessness. This means the server has short-term memory loss. Every single request you send has to contain all the information needed to process it. Second, it's resource-based. Everything is a thing, a user, an order, a photo, and each of these things has a unique address. And third, there's this thing called HADOS. Yeah, it's a mouthful, I know. But the idea is super simple. The API itself tells you what you can do next. So when you look up an order, the response includes a link you can follow to, say, cancel this order, or view shipment status. It's like a self-guided tour.
And those big ideas lead to a really simple logical structure. Good naming conventions are absolutely key. You use plural nouns for groups of things, like /users. You build clear hierarchies, so /users/123/orders is just instantly obvious, right? It's the orders for user 123. And then you use question marks and query parameters for filtering and sorting. It's predictable, logical, and just makes sense.
All right, our architectural plan is solid. Now it's time to pick up the tools and start building. We're shifting from design to implementation. And Jakarta REST is what gives us the power tools to turn that blueprint into actual working code that delivers on all those promises.
The magic of Jakarta REST is really its simplicity. You just start with a regular plain old Java class. Then you add these little markers called annotations. Think of them like sticky notes for your code that say, hey, this part does something special. And just like that, those annotations transform your simple code into a powerful web endpoint, saving you from writing mountains of tedious boilerplate. Let's look at the first big one, @path. This is how you give your API an address on the web. It's like putting up a street sign. By adding @path/users to your class, you're telling the server, hey, any web traffic for the /users URL, send it right here. This is where it lives. Okay, so you've got an address. Now you need to say what can happen there. The @get annotation hooks up a piece of your code to handle read requests. It maps directly to the standard HTTP GET method, which is the universal verb for I want to fetch some data. So when a browser or another service asks to get something from your path, this is the code that runs. And following that same exact pattern, the @post annotation is for creation requests. So when a client wants to create a new user and sends an HTTP post request to that /users path, the code you marked with @post is the code that gets executed. It's just a really clean, declarative way to map your logic to how the web already works.
So, we've designed it, we've built it, but what good is it if no one knows how to use it? It's basically useless. So the next step is absolutely crucial. We need to create the user manual.
We need clear documentation that tells everyone else how to talk to our awesome new API. And for this, the undisputed industry standard is called Open API. You can think of it as the universal language for describing API blueprints. It generates a formal contract that details every single endpoint, every parameter, and every possible response. And because this contract is machine-readable, it allows both human developers and automated tools to understand your API perfectly.
Now, here's where it gets really cool. That documentation lives right inside your code. By using more of those little annotations like @operation to describe what an endpoint does, or @schema to define your data, you can generate beautiful, comprehensive documentation automatically. This is a huge win because it means your docs can never be out of date. They are generated from the exact same source as the API itself.
Okay, so let's recap. We have a working API, it's well documented, the user manual is printed and ready, but how does another application, another service out there, actually pick up that manual and start talking to our API? How do they consume it? Well, you've basically got two main ways to go. The traditional Jakarta REST client is super flexible. You build your request piece by piece, programmatically, which is great when you need fine-grained control. But then there's the more modern way, the micro-profile REST client. With this, you just define a simple Java interface that looks like the API you want to call. And that's it. The framework generates the entire client for you. This is what we call type-safe, and it's amazing because it means the compiler can catch a whole class of bugs before you even run your code. It's less work and more reliable.
So, building an API and using an API, that's one thing. But making sure it can survive and actually thrive in the chaotic, unpredictable world of the modern cloud, that's a whole different ballgame. This is the ultimate proving ground. This is where our API has to get tough.
Look, in a distributed system, failure isn't a possibility. It's an absolute certainty. Something will go wrong. The Fault Tolerance API gives you the toolbox for that reality. Think of it as a safety net. It gives you patterns like circuit breakers, which are smart enough to stop calling a service that's failing, preventing a cascade. And it gives you fallbacks, which provide a sensible default answer instead of just crashing. It's all about building systems that can heal themselves. Your API also needs a way to communicate with the cloud platform it's running on. And that's exactly what the Health API is for. It creates standard web addresses like /health/live that an orchestrator, like Kubernetes, can ping constantly. It's like the API is raising its hand and saying, "Yup, I'm alive and ready for work." This is how the cloud automatically knows if it needs to restart your application to keep things running smoothly. And finally, think about this. In a microservices world, a single click from a user might trigger a request that travels through 10, 20, or even more different APIs. If something slows down, where's the problem? It's like finding a needle in a haystack. The Telemetry API is the solution. It enables distributed tracing, which gives you this incredible X-ray vision to see the entire journey of that one request, making it possible to find bottlenecks and fix those really tricky bugs. So there you have it. From that first architectural drawing to a resilient building standing strong in the cloud, we've seen how APIs are truly the blueprints of our entire digital world. They're the contracts that define how everything connects and communicates. The only real question left is, with all these tools and blueprints at your disposal, what are you going to build next?